Hello and welcome to a new very interesting video. This video is about this device here. I got this from a friend and he is part of a band called Half Baked Cheese. So if you want to check them out, I've put links to their pages into the description of this video. So just scroll down to the video description and you can find some interesting links. Okay, and he wants to use this device in his band as some sort of microphone preamplifier, and that's why he purchased it. And my task is now to find out what this thing exactly is, because his guess is it's somewhat of a microphone preamplifier, but yeah, I have to analyze it to find out what it is exactly doing and for what it can be used. Okay, and then second, I have to restore or repair it, because I don't think that this thing is working. It looks pretty old and yeah, I don't know if it is working, so I have to check out if it is working, and if not, what needs to be done to repair it, and to diagnose it, which parts needs to be replaced, and also how expensive this might be to get this going again. Okay, so let's start with analyzing this thing, so to find a bit more what this could actually be, and if this actually is some sort of microphone preamplifier or amplifier. It came with some cables. So first of all, it came with this cable here, which is the power cable, so it plugs right into here, and there we have our volt plug. So this is good that this was included. And it also came with this cable right here, and this cable, this plug, this connector here plugs right into here. So this arrow must be pointing up like this, okay, and now it fits right into here, and also in the other in all of these four connectors here. And on the other side we have our XLR connector, which is a very common microphone connector, so it looks like it is a microphone amplifier. And it also came with some other cables which have the same connector on this side, so they were also included, and here we have another one. Okay, so this already points to the conclusion that this might be a microphone amplifier. So yeah, so let's take a closer look at the controls, what it is, and let's see if it actually is what we are thinking that it is. And the whole thing looks like commissioned work actually, because if you look at these labels here, so they are sticked on here with tape, and also the overall look of this thing. So I think someone asked a workshop or so to build this thing for one purpose, so there might be only one thing of this in the whole world. So this is a one of its kind thing, so this might be the only one of this which exists. So because I think maybe if it is commissioned, then there was only this one thing was manufactured and not more. Okay, yeah, so but now let's look at the knobs and let's see what we can find out from that. So let's start with the left hand side, because this is obviously the input. Okay, so here I've zoomed into the connector, and as I showed you before, we have this adapter from this connector to XLR, so it's a bit similar with XLR. At least it has the same number of pins and somewhat the same layout. Okay, and okay, and then next to the connectors we have these switches, so each connector has one switch, and here I can turn it on or off. And this switch down here, the plastic is missing from this switch down here, and there it says Bedämpfungswiderstand 600 Ohm an Buchse. So this means attenuation resistor 600 Ohm at connector. What this means, actually, this could be some sort of attenuation which you switch on and off, or maybe you turn the whole connector on and off. Okay, so it could be both, and it seems that the lower position is maybe on, because there it says on 600 ohms ein, which means on, so it might be now on and now it might be off. We will find out later. Then next to it we have this potentiometer and this knob here, and if we go down a bit, then the lower two connectors also have a potentiometer and a knob. This knob is also the plastic piece is also missing for this knob right here. And what I think is that these two connectors are controlled with this potentiometer right here, and the lower two connectors are controlled with this potentiometer right here. And what this potentiometer is doing, actually, if you look carefully down here, then we have it says Mikrofon 1 plus 2 gezogen minus Bass, gedrückt plus Bass, which means in English microphone 1 and 2. So this might be these two connectors right here. And then gezogen, which means pulled, because you can pull it like this. Then it says minus bass, which means maybe that it decreases the bass frequencies. So this is some sort of filtering going on here. And pushed means this, so this is gedrückt, which means pushed. And then it says plus bass, so which means that it might increase the bass frequencies. So the low frequency response might increase when it is in this state. So this could be the case. And then we have this switch here, which has different positions. In the middle we have the normal position, and then it says minus Höhen and plus Höhen, which means in English minus treble and plus treble. So this might increase the high frequency response. So there we can switch some low and high pass filters on and off with these switches maybe. So we'll find out more about this later. And we have the same down here. Also the microphone inputs and the high and low frequency attenuation thing, or yeah. So this might be the input control. And then if we go further here, let me zoom in a bit. Here then we have something like Summenregler, which means sum control. So maybe both channels then get mixed together. So all of the microphone channels get mixed together, and with this you can control the level or the volume of both microphone channels together, because it's the sum control of this. And then down here we have something, there is Toneingang 1 plus 2, gezogen minus Bass, gedrückt plus Bass. And in English this is audio input 1 plus 2. And then we have also we have again gezogen, which means pulled. We have plus bass, and then we have pushed minus bass, and then we have also this knob on the side, which has again this treble. So we have minus treble and plus treble. So these two controls are one set actually. And what does this Toneingang mean? I think if we go down a little bit, then down here we have Toneingänge, which means audio inputs. So this might be audio input 1 and audio input 2. Then we have these switches here, which might turn them on or off. And then we have these connectors here. And these connectors could be the audio inputs. And then we have also these banana plugs, which could also be the audio inputs or ground reference. So these are actually plugs. So there is... do I have something similar to this here? Yes, I have something similar. So this might be plugs like this one here that fit into here, okay? So because we have shielding on the outer side and in the middle we have the signal, so it might be something similar to this, which plugs into here, okay? So these are actually these audio inputs. I think these must be line inputs then, okay? So the four on the left side are microphone inputs, and these might be two line inputs which you can switch on separately. So for example, if you use this, you can talk into the microphone, and then maybe you want to play some music from a source like a tape recorder or so, then you connect the tape recorder here, and then you can switch the tape recorder on, or you can switch the input with the tape recorder, connect it on with this switch, and then you will also hear the tape recorder, and you can mix them together with this, so we have some sort of mixing console actually in here. Okay, so let's go up here. What else do we have? Here we have something called Ausgänge, which means outputs in English, and NF, which means low frequency or audio frequency, and here we have 100k, which might be the output impedance of this connector. So we have 100k ohms output impedance, and these are audio outputs. And down here we have these outputs here. So we have 1, 2, 3, 4. This again might be either ground reference or also signal. I don't know, I have to check later on. Or maybe we can check it right now. Let's see if this is connected to ground actually, because I just used the multimeter. Okay, so here I have the multimeter in ohms mode, and let's find out if these are ground. So for this I just connected somewhere to the chassis where we have ground. And now let's see, what do we have? We have 0.3 ohms, so this is ground, this is ground. Down here this is ground as well, and these here are also ground. So okay, this makes sense because they are black, so they are ground reference. You can plug in the ground, and signal is in the center of these blocks here. So yeah, again, these are now the outputs for the audio frequency, and I think these are line outputs actually. So we have 3 line outputs here, and yeah, so you can use 3 different line outputs. And then let me go up again here, okay, and then we have these 2 connectors, so this output here, and it says Kontrollverstärker Ausgang, which means control amplifier output. And this, or in English, monitor amplifier output might be maybe a better translation. And I think you can connect a loudspeaker here with 5 ohms impedance, and then you can listen to your microphone or to your line inputs. And here we have this switch, which has no label, but maybe it turns this control output on or off. Okay. So, and speaking of control output, we have something else to for control here, which is this big thing here. So first, it might look like a bit like a PC fan, you know, because of this, of the way how it looks. But actually, there's a loudspeaker behind this. So this is a monitor loudspeaker, and down here we have also this potentiometer here, which says Control LS. Which might which is a control or monitor loudspeaker. So with this you set the volume or the level of the monitor loudspeaker, of this thing right here. So actually it has a built-in loudspeaker. I don't know how much power it has, but it has, at least it has some sort of monitoring going on here. And underneath the loudspeaker, which is this here, we have, this is a voltage selector. This just, you can unplug it like this. Then we have multiple pins in here, and this is just a voltage selector. So the transformer in here might have different tabs, and with this you select which voltage you want to have. And then if we move further to the right, we have this switch here, which is aus, ein. It is just off and on. So now it's on, but let's switch it to on or to off. So now it's off. This is a power lamp, I think. Then here, these are fuse holders. So we have some fuses inside here. Okay, so we have some fuses inside here. So what I could do right now is I could actually check them to see if they are good. So we can already do some testing beforehand. So let me use my multimeter again, and since it's a fuse, I can also switch it to continuity. Okay, there we go. And here we have the first fuse. Okay, so this fuse is good. Let's do the next one, which is this one here. Let's see, oops, let's see. This one is good as well. Okay. And let's see what is this fuse. Let's see if this is also good. Do we have 3 good fuses? No. Actually not. No, this fuse is open. Okay, so we have one blown fuse, and this fuse has 200 milliamps. So we have one open 200 milliamp fuse. So this might be the fuse for some HD in here, for some high voltage in here. Yeah, so maybe we have leaky capacitors in here. I would have expected leaky capacitors anyway, and maybe we have leaky capacitors and someone turned it on, and then the fuse just blow because of the leaky capacitors. We will find out later. Okay, but let's put it back into here. So there we go. And what else do we have? Of course, the power connector. Then interestingly, we have two plugs with 220 volts marked, as you can see. So maybe the power connector is just routed to here, so it's just in parallel, and you can connect an auxiliary equipment which also needs 220 volts to these plugs, to this port here. So maybe, and this up here is actually a voltmeter. Interesting. So this might monitor the voltage from the power connector here, so you can check how high your voltage is. It's interesting that they have it in here, but it's there. Okay, so let's zoom out again. And what we can also notice here is these stickers are here. So we have 3 stickers on here, and let's zoom into one of them because they are all the same. So let's zoom in here, and what does it say? It says Elektroradio Fernsehen Meisterwerkstätte Helmut Bühringer, which means electro radio and television master workshop Helmut Bühringer. It's from Linz, so this might be manufactured in this master workshop in Linz. We also have a telephone number here, and yeah, this might be the place where it came from. So as I said before, this might be commissioned work, so it's custom made, and it was made in this workshop, maybe, or it was repaired in this workshop. So both is possible, but I think actually that it was made there. And if we move to the right, then we can see here it's also the same sticker as mentioned before. So yeah, I think this is where it was made, or at least serviced or repaired. So we have also the same sticker at this power connector here. Alright, so here you can see the whole thing again in all its glory. And what's the next logical step? The next logical step is to take it apart and analyze it and see what it actually is doing, and also see what do we have to do to make it work again. So how much is needed, how many components do we have to replace, and yeah, how expensive would this be? It's also interesting, of course. Yeah, so let's open it up, analyze and diagnose it. Okay, since the fuse was blown, I'm pretty sure, or this fuse actually, since this fuse was blown, I'm pretty sure that something in here is going on, that something in here is broken, something needs to be repaired. So this will also, we will also diagnose it, what this something is, and I already expected this something is there are some capacitors in here which are leaky, which are heavily leaky. Okay. Okay, alright, so how do we take this thing apart actually? There are no screws on the back, no screws on the bottom. There is basically, there's on the top there's only this handle, and of course this handle has screws, but I don't think that this has something to do with how this thing is assembled. So the only screws that holds this panel here on the housing are these 4 screws, I think at least. And so I will unscrew them, and let's see if we can open it up that way. So let me just unscrew this screw. So it's really exciting to find out what's going on in here. Okay, so this one, and the panel already gets loose a bit, and one more to go. So this is the last one, and yes, okay, so there we go. There we go. Alright, so now the panel is loose, and okay, we can just, I think we can just slide it out. Yes, it's heavy, but we can just slide it out that way. So let's see. Okay, so I was able to slide this thing out of its case, so the whole chassis just slides out, and now here you can look, this is the case, so now there's nothing left in here. Yeah, so alright, so I will turn this thing now around so that you can see the inside of it, because this is now super exciting to see it. Okay, alright, so here you can see the chassis. So let's first of all, let's have a look at the top side of it. So what do we have here? We have a huge power transformer, of course, which supplies the tubes and the filaments. Then we have this thing here, and down here we have another transformer. So this thing only has two connectors. So this is a filter inductor. So this is for filtering, and since there's only one transformer left down here, this must be the output transformer for the loudspeaker, because vacuum tubes are high impedance devices, and this is a vacuum tube amplifier. As you can see, we have tubes in here. So this transformer is to match the high impedance of the tube with the low impedance of the loudspeaker, so therefore we need a transformer. So this must be the output transformer for the loudspeaker here. Okay, so what else do we have? We have these capacitors here, and they might be leaky, so I have to check them with my capacitor leakage tester, which I repaired in another video, by the way, this Heathkit capacitor leakage tester. And then we have these capacitors here. They also might be leaky, so we have to check them. Yeah, so these are filter capacitors for the transformer. So since these are filter capacitors, we also need some sort of rectifier in here, and I'm pretty sure that this here is the rectifier. So let me show you the thing a bit closer. Okay, so here we have a look. So I think this is the rectifier tube, because as you can see, it has these two sections here. So this looks like a double diode, actually, a double diode. So this is a rectifier with double diode. So this might be a transformer with a center tap, and then one side goes to one anode of the diode, and the other side goes to the other side of the diode, and then we have both cathodes together, so common cathode thing. And this here is this diode thing. So this here is the rectifier, I think. So let me plug it back into here. And by the way, if you have tubes with such a socket, then don't pull them like this. Pull them at their socket here, because otherwise you might destroy the wiring in here, and then you might destroy the tube, which is not good. So always pull them on here. Yeah, so let me plug it back here. Okay, there we go. So yeah, let's have a look at the tube. So here we have one tube, and these tubes are here inside the shielding here. And by the way, we have one tube missing. So let me zoom into this portion a bit, and if you look down here, we have a socket but no tube. So this tube is missing, so I have to find out what tube this is or was actually. And yeah, let's start with the first tube, which is this one here. Okay, so let me pull it. There we go. So what is this? It's nothing, it has no label. Okay, but from the way how it looks, I would say that this is a pentode and AL84 actually. It's an AL84. So this is the pentode which drives the loudspeaker actually. It is a very common power amplifier pentode, and I think that this is what it is just from the way how the system in here looks. Yeah, unfortunately the label is gone, but I'm pretty sure that this is what it actually is. It's the AL84. Okay, so back to the complete thing. Now let's have a look at these shielded tubes here. So let's start with this one and let's see what this is. Okay. Oh, there we go. We have an AF86. So what is the AF86? The AF86 is also a pentode, but not for high power output. This is just for low power, so this is for small signals, so just for some sort of preamplification. And the AF86 was very commonly used in microphone preamplifiers. So this is indeed a microphone preamplifier, and it uses the AF86. And the AF86 was introduced in 1954, I think. So this gives us some clues of how old this amplifier is. So since this was introduced in 1954, this amplifier must be newer than 1954, of course, or 1954. And now let me plug it back in here. Okay, so what else do we have? Let's move further to the right and zoom in a bit. So here we have two other tubes, and let's see what these are. So we have this one with a cable, and this is the socket is a bit loose here. Okay, and what do we have? It's another AF86. There we go, another AF86 tube. Okay, alright. So let me plug it back into here and connect it to here. There we go. And back here, what do we have? Okay. Okay, this is again nothing, but maybe this is another AF86. Yeah, maybe this is just another AF86 with no labeling on here. Okay, so let's plug it back in. So from that, maybe the missing tube is also an AF86. Okay, alright, so that's for the components on the top side of the chassis, and let's look at the bottom side what we can find down here. Okay, so let's do that. Okay, so here we're looking at the bottom of this amplifier. So there's also a bit going on here, as you can see. Okay, so let's start right up here and find out what the components are. So here we have these two strange things here, so let me zoom in a bit. Okay, so these two devices are the transformers for the microphones, because they are connected to the switches here. So we have two of these transformers, and one is connected to this lower switch here, and one is connected to a switch up here. And actually the lower two microphone inputs are connected to these switches here, and then the output of the switch, so to speak, is in parallel. So these two switches are in parallel, and then they go to this transformer. And for the upper two inputs, it's the same, they are also in parallel, and then they go into this transformer here. So with this switch you can turn on and off the microphone separately, but we only have two transformers. So this means that we have only two separate microphone inputs, so to speak. So we have four, but it can be switched, and then we have actually two separate inputs, two individual inputs, because we have only two transformers. And we saw it before because we only had two potentiometers for the microphones, So this it was already an indication that we have only two separate inputs, and here we see it with our two separate transformers. And then the secondary of the transformers might be connected with the grid of one of these EF86s. So since we have two tubes on the other side here, one transformer might be connected to one tube and the other transformer might be connected to the other tube, and here we have our preamplifier. Okay, so if we go down further a bit, then we can see a lot of capacitors here, and these might be capacitors for coupling the anode of one tube with the grid of the other tube, so that we block the DC. And this is also something that we have to check if these capacitors are okay, because if they are short or heavily leaky, then they might destroy the tube. So we cannot turn it on without having checked them, because otherwise we might destroy something, which we clearly don't want. So if we go down further, we see more capacitors and also resistors, and down here we have the loudspeaker output transformer. So this transformer is for the loudspeaker, okay? So for this AL84 is connected to this transformer and then to the loudspeaker. Okay, so one interesting thing is that this switch, which I haven't talked before actually in the switch exploration video, isn't connected to anything. So this is interesting. So if we zoom in here, no cables are connected to the pins. So this switch performs no function in this device. Maybe it has at some point before. Let me move the camera a bit so that you can see it better. Here, because here we see a little bit of old solder on here. So there might be something, maybe there was something in here and now it is not longer in here, I don't know. Or maybe this was just a used switch and was never connected and it was already and they just put it into here because they were thinking they could use it for something. Okay, so then now the next step is to diagnose and evaluate what needs to be done to get this thing working again. Okay, so and there is one thing that we don't do, and this is to plug it in right away, because if we plug it in right away, then we might destroy a lot of other components unnecessarily, because these capacitors, for example, if they go bad, then they might destroy tubes inside here, or if the filtering capacitors for the main filtering capacitors, these aluminum capacitors, if they go bad, then they might short and destroy the rectifier tube or destroy your power transformer. So there is high danger of destroying other valuable components in here, and you don't want that. So first of all, we have to check the individual components with component testing devices to make sure that the components are fine, or to check their condition, and after that we turn it on. Okay, so I will start by checking these capacitors here. So let me zoom in again. So first I will check these capacitors here, and this is made by Kapsch, by the way. As you can see, it's made by Kapsch. It's 0.1 microfarad 500 volts capacitor, and I will check if this thing is leaky or not. So how do I do that? Actually, to check this, I have to unsolder one pin, because the leakage tester applies a high voltage to it, and I could potentially destroy something in here. And also, if there's something in parallel, then the result will be wrong. So I have to desolder one pin here carefully. Okay, there we go. So now I've desoldered one pin. And now I can connect my capacitor leakage tester to it, and these capacitors are not polarized. However, they have an outer foil is marked with this side, so if I replace them, I have to make sure that I replace them in the right direction, so that the replacement has also the outer foil on the same side to get maximum performance out of this, because otherwise it could be unstable or just not perform as good, because then some interference might couple into the capacitor. So I have to check the replacement capacitor where the outer foil is. Okay, and I've made a separate video on that, so just go to my channel or go to my videos and check this out if you're interested. But yeah, now let's test it if it needs to be replaced. Let's have a look. So for that I will just connect 2 crocodile clips. So one on this side and one on the other side. There we go. And now let's move to the capacitor leakage test, and of course make sure that you don't touch anything with one side, so that it's out of circuit with one side, and also that your device is not plugged into power, of course. So this whole thing is floating, so to speak. So let's move to the capacitor tester. Okay, so here's the leaky capacitor tester. Actually this thing had leaky capacitors in it and I had to replace them, and there's also a separate video on this, so check that out if you're interested. And how does this work? Actually, first of all, make sure that the voltage is set to the lowest voltage and this switches to discharge, because later we will switch it to leakage to test the leakage, but now it's on discharge. And now I turn on the thing. Now it's heating up, and this is also a tube device, so it needs some time to heat up. And this tube here, this I tube, then will indicate if the capacitor is leaky or not. So depending on if this I tube opens or closes. So now if it is in a state like this afterwards, then it won't be leaky, but if it closes, then it's leaky. So now of course I have to connect the capacitor to it. So this was the first lead, and now also the ground lead. This uses high voltage, so don't touch the capacitor or something else. Again, make sure that the capacitor is one pin is removed. And now I switch it to paper mica in the paper mica mode, because this is what we need for this capacitor, because this is some sort of paper wax capacitor. And now I switch it to leakage. There we go. And as you have seen, it went closed for a short time. This is because it was charging, and now let's see if it is leaky or not at its operating voltage. So we cannot go above 500 volts, because then we will destroy it. So let's just move up and see what it does. Okay, okay, still okay. Good. Alright, so now at 200 volts it's just closed. As you can see, at 200 volts it's not working anymore. If I go back to 150, it's fine, but at 200 it's not working anymore. And this thing is rated for 500 volts, so we have a leaky capacitor here, unfortunately. So this one is leaky. And before disconnecting the capacitor, of course, you have to safely discharge it, because this capacitor is now charged with 200 volts, even though it has a very low capacitance. But it's always better to make it safe. And so I switch this to discharge, and you can see now it's discharged. And now let me connect another capacitor. Alright, so here I've connected another capacitor to the capacitor checker. As you can see, I've also desoldered one side, I've connected it. And this is has the same properties than this one has. It's the same capacitance and it has the same voltage rating. And now let's have a look at the capacitor tester. It's currently at the discharge, so now put it into the leakage mode, and it's still at paper mica. And as you can see, the eye is open, so at 3 volts it's not leaky. And let me increase the voltage. Okay, at 150 it starts to leak. Okay, and at 200 it's leaky. So we have found another leaky capacitor. Okay, so let me discharge it again. There we go. And from that I would conclude that I have to replace all of these capacitors, because if 2 are leaky, then the others also might be leaky. So I have to replace them to get this back working again. Okay, so these capacitors have to be replaced. So let's check the electrolytic capacitors on the other side. So let's check these ones here. So these ones are the next that I will check. So these big capacitor here are actually 2 capacitors in one housing. So you can see this because on here we have 2 times 32 microfarads, and this means that we have two 32 microfarad capacitors in here, and then they come to a common point. So the negative is common, and the plus, we have two separate 32 microfarad plus connections here. So this is a capacitor which has three connections. So the two separate capacitors are connected to plus, and then one common ground connection for both capacitors. Alright, so I also have to unsolder one connection, and what I will unsolder is now the ground connection. Then I will connect the capacitor leakage tester to it. Okay, alright, so this is the bottom side of the capacitor. Here we have the three cables coming out, and this was the common minus, so I've desoldered it. So now it's important when hooking up the capacitor checker that you connect them the right way. So the minus goes to minus from the capacitor checker, and then the two pluses, and then we have this cable, and here we have one section, and here we have the other section. So now I will check one of the sections. I will just connect it to here, and again make sure that this is not connected to somewhere else by accident. And yeah, let's look at the capacitor checker. Okay, so here we're looking at the capacitor checker. Now I have to switch it to electrolytic here. So this was on paper, but now I switch it to electrolytic. And again, make sure that you don't switch it to a voltage higher than the capacitor is rated to. So in this case 500 is the limit. Now I put it to leakage, and at 3 volts it's not leaky. And now let me just increase. So you can see it's charging at 250, at 300. Okay, now it's a bit slow, but it is charging. Okay, it could be also reforming now a bit, so it could be possible that I can reform these capacitors just by letting them sit on a voltage and wait until they reform, because this is possible with these capacitors. And note with reforming is that if you reform a capacitor, you have no guarantee that it will work for a long time, so it can fail any time actually. So therefore be aware of that. So if you want to make your repair permanent, then a replacement might be a better option. And yeah, but I think this thing is now reforming, because it's, as you can see, if I switch it to this position, it's very slowly going up. So I will let it in this state for a while and see if I'm able to reform the capacitor. Okay, so after a while you can see it has opened up a bit more, so this means that it is actually reforming. Yeah, but I will test it more carefully later on, and again I recommend replacing them, because even if it reforms completely, then you might not know if it will fail soon or not, and so therefore I would highly recommend replacing it. Yeah, so that's for this capacitor. Okay, so let's check another one. Let's check this one right here. So let me unsolder it first. There we go. And now I connect my capacitor leakage tester again to the capacitor. So let's do that. Yes, there we go. And let's see what this does. So again, I'm in the paper mica position. It's now on discharge. Let's put it into leakage. Alright, and we are on 5 volts and it is already closed. So that's short actually. What happens if I put it into electrolytic, because electrolytic is less sensitive. So let's see. Okay, and it is shorted at 50 volts. So this capacitor is completely broken. It has almost turned into a wire actually. Alright. Okay, so let me confirm that this capacitor is more wire than something else. So here I have my multimeter in ohms, and now I connect the capacitor to the multimeter. And as you can see, we have 0.2 ohms, 0.3 ohms, so this capacitor is definitely more wire than a capacitor. Okay, so they definitely need to be replaced, otherwise we would destroy a lot of stuff in here. Alright, so what else do we have up here? So let me zoom in a bit. We have still this capacitor here to test, so we have several of these capacitors here. They are made by Philips, by the way, I think. And we have 1, 2, 3, 4, 5 of them. And let me move it a bit out of its housing. So there we go. And if I turn it, then you can see it's a 100 microfarad capacitor rated for 30 volts. It's polarized, it's electrolytic. And now let me check how what the condition of this is. So of course, with the capacitor leakage checker, now I have to desolder one wire here. So there we go. And now let me connect the capacitor leakage checker. Again, it has to be on discharge and on the lowest voltage range. So here we have the plus, and here we have our minus connector. Okay, alright, so let's see what we get. So here we are at the capacitor leakage checker. It's set to electrolytic, discharge, and voltage the lowest. Now let me put it into leakage. Okay, this is fine. Let's go right up to the voltage. We're at 25 volts. This capacitor is rated for 30, so we cannot go higher than that. And this looks pretty good. We have no leakage here. Great. Okay, alright, so now we've checked all the capacitors, and yeah, what's next? Now we know that the bottom capacitors here have to be replaced. We know that it might be better to replace these capacitors here, and we can also replace this one because they are not expensive. The most expensive capacitors are this one here, to find a replacement which looks similar but is new and working. But before I can do that, before I can start, I have of course to ask the customer, so to speak, if he wants throw money on this thing and if he wants new capacitors for this thing. But there's one very important thing to note before doing that, and this is to make sure that after replacing the capacitors that there's no problem left afterwards, because if for example this transformer here is broken and you replace the capacitors and afterwards you find out that this transformer is broken and it is maybe expensive or hard to obtain or even not to obtain, okay, then you have a problem, because then the customer has paid for the capacitors and the thing still isn't working, and it might never work because of a very expensive unobtainable part, okay? So we have to make sure that before we start to replace the capacitors, or before we tell him, okay, I can replace the capacitor for and then it will work, we have to make sure that there are not any other components in here which are hard to obtain and which might be broken, okay? So I have to check all the other components before I will tell him and ask him if he wants the capacitors to be replaced, so that we have evaluated everything and so that we know that we can get it to work again afterwards the capacitors have been replaced. Alright, so we have to continue this evaluation right now, and I would say the next part to evaluate or the next parts to evaluate are the tubes, because they are easy to check and they are not that inexpensive, so it will cost a bit to replace all the tubes, and therefore I will continue checking the tubes. And for that I will start with this one, with this AL84, at least I think it's AL84, but it's not labeled. And I have a tube tester, and with this tube tester I will check the vacuum tubes if they are fine, okay? Yeah, so let's get right into it. Okay, alright, so here we have our vacuum tube tester, and first of all we have to set it up for the tube, and for this we have this sheet here which contains the different tubes. So here on this side we have the different tubes, and here we have their properties, and now I need to set it up for the EL84. So here I have my EL84 on this sheet, and the only thing that I have to do with this thing is to set it to the right position. So the heater voltage, for example, is 6.3 volts, and I have just to align the knobs in the same position as it is mentioned here. So I have to do that, and I will do that. Okay, so now I've set up all the parameters for the AL84. So I have also this convenient ruler up here to see what it is, and actually you have these numbers here, and then these numbers here, and then you align the knobs in the same position as this is. Okay, so now the next step is to put this knob into the first position. In the first position it will check the filament if it is shorted or not, or if it is open or not, sorry. It will check the filament. So if I turn on the thing now, this lamp lights up, and now you can see this arrow here is going down. So let me do it again. So now if it's off, it's at 0, and now it's going down. This means we have an interruption in the filament, so the filament is open, which is of course the case because we have no tube inside inserted. And now if we insert the tube, it goes up to 0. So this means that the filament is fine. And now the next positions here are for checking if there are any shorts between different pins of the tubes, and there are not. So we can go up more and more and more. And in the uppermost position it will perform an emission test of the tube. So for this it will put the grid at 0 volts, and it will measure the current, how much current flows through the tube, and depending on the tube it's a different value, which is set with the knobs here. And now it shows you how many percent of the value according to the datasheet of the tube the current is. So how much current flows in relation to the current that should flow according to the datasheet of the tube. And here we have now our result, and let me zoom in. There we go. And as you can see, we are above 100%. We are at 106% actually, to be precise. So we are at 106%. So this tube is working fine. So our EL84 is working fine. Okay, so we have a perfectly working EL84. So now let's put this to off, disconnect the tube and turn it off. And now let's check the other tubes, the EF86s. So now I have to set the parameters for the EF86, and I will do this right now. So first of all, I will clear everything so that I don't miss something. And now I set it up. Okay, so now we have a setup for our EF86, and here we have our EF86, and now let me plug it in. There we go. So we have actually 3 EF86 in here, and this is the first one. And now let's see what we get from that. Okay, alright, so let's see how this is doing. So first of all, let me turn on the device. So now it's on, and as you can see, the filament is not open because otherwise it would dip below 0. So again, if I remove it, it dips below 0, but it is not open. So this is how it should be. So now let's check for shorts. Okay, that's good. And now let's go into the emission, and it goes right up, and we're above 70, we're above almost 80, so almost 80%. Okay, so could be better, but is still usable. We have 80% emission, could be better, but still usable. Okay, so yeah, let's turn it off and let's do the next one. Okay, alright, so now let's check our next EF86 and let's see what we got. Nothing. So as you can see, the filament is broken on this tube. So this tube has a broken filament. That's unfortunate. That's very unfortunate. So we have one broken AF86 in here. Okay, so we have to replace that one. So another point of a component that needs to be replaced, so that I don't have to do the other checks, because if the filament is broken, then it makes no sense. Alright, that's unfortunate. So now let's check our last EF86. It's this one here. Let's see if we have more luck with this than with the one we had before. Okay, and the filament is working. This is great. So now let's do all the tests. And what do we have? Has it some emission? Yeah, it's starting to go up. This is good. And we are in the green area already. And we are above 80%. We are almost 90. Okay, we are above 90%. Okay, so this is a good one. This is a winner. So we have another good tube. This can be used. There is no need to replace this one, of course. So we have another good tube. This is great. So we have above 90. We have 95% actually. So this is very good. This is a very good tube. Great. Okay. So this concludes the test of the tubes, and now let's move on. Okay, alright, so what's next? There's still one tube left that we have to test, which is this one, but I will test this afterwards off camera, because I don't, or the tube tester does not have the right socket for this one, so I would have to build something for it or test it a little differently, but I will do this afterwards off camera. And let's continue with some components on the bottom side. Okay, so let's turn it around again. Alright, so now I will test the output transformer and the loudspeaker at the same time, and this is actually pretty simple. You just have to find the primary winding of the output transformer, which is this. So this is the primary, this is the side which is connected to the AL84 output tube, and on here I will just connect my function generator. So if I move the camera up here, then you can see up here, this is my function generator. It's already turned on. It's set to 1 kilohertz. It has some output, and I've connected this to the output of the function generator. So this coaxial cable here, and then at the end I have these two clips, so I can clip it to the transformer. Let's do that. So here we are back, and let me connect it. So here we have the first and the second, and as you can hear, it's working. So the output transformer is working, and the loudspeaker is also working because we can hear it. So as you can hear, it's working perfectly. You could also check it with an oscilloscope to make sure that it's working perfectly fine, but it sounds clear. And yeah, since no scope, no fun, let's hook up an oscilloscope. Okay, so now I have connected the oscilloscope to the loudspeaker directly, and now I'm about to connect the function generator to the output transformer, but first of all let's move to the oscilloscope. Okay, so zoom in a bit, and here we're looking at the oscilloscope screen, and now let me connect the output transformer to the function generator. And there we go. Let me magnify it a bit. And what we have here is a beautiful sine wave. So it's working perfectly fine. I can change the amplitude on the function generator, and it's working as expected. So this output transformer and loudspeaker is working perfectly fine. So both the loudspeaker and the output transformer are a winner. So what's next to test? If we move up here, then we have these two nice little microphone transformers, and I will test these two next. And for that I have to figure out how they are connected, and actually I'm pretty sure that this is the input, so I can directly connect the function generator to the microphone input plug. And to find out where the output is connected, I have to unscrew them. And it seems that they are held in place with two screws which are here at the top. And so let's see if this is true. So here we have the first screw unscrewed and the second one. Alright, okay. Interesting. They have used nuts as spacers for the screws. That's interesting. So to show you, they have used this here as spacer for the screw, and also this here as spacer for the screw, because these nuts are too big to fit through. So if I put them on the screw, so they are too big, so they won't they won't not be fixed on the screw. They have used them only as spacers. But okay, anyway, let's see how this is connected. So let's have a look. As I told you before, the primary of the microphone transformer goes directly to the microphones or via the switch, and then the secondary one wire goes to pin number 9 of one EF86, which I think is the grid, and the other pin goes right to this point, which might be ground. So to check that, I use the multimeter and I put it into continuity mode. So there we go, and let's see if this is actually ground by just connecting it here and on the other side somewhere where I know that is ground. And as you can hear, this is actually ground. And now let me verify that this here is actually the grid of the AF86. For this we will use this book here. This contains data sheets of tubes and semiconductor components. And now we have to find our EF86 in here. EF86, EF89, 86. So there we go. And here, this is the EF86 page, and if we look down here, you can see that pin number 9 is the control grid of the tube, which is great. So our assumption that this is connected to the control grid of the tube is right, because it is the only way that it makes sense, of course, in this configuration here. So this is how it is. So now let's see if we can check this transformer. And I will just do that by connecting the function generator to the microphone input, and then see if I get any output on the secondary side of the transformer, and I will measure this with the oscilloscope. So the easiest way to do that is to actually mount the transformer back at its original position and probe the signal at pin number 9 of the tube socket. So let me do that. So first of all, I will mount the transformer. Okay, so now I will connect my oscilloscope to pin number 9 of this tube here, actually to the tube socket, because I don't need the tube in place for this test, because I only want to test the transformer. So I remove the tube like this, and then I connect it to pin number 9, and the other side has to be connected to ground, of course. And I know that this point is ground because I measured it before. That this pin of the capacitor is connected to ground. And the next step is to connect the function generator to one of these two inputs and make sure that the input switch is on. So I will connect it to the upper one first. So let's connect this. So this will then also test the switch, the input switch, of course, because it has to go through the input switch. And now let's look at the oscilloscope. Alright, so everything is connected, and let's look at the oscilloscope. Let's see what we get. So let me turn on the function generator, and there we go, we have a signal. So this is great, because this means that the switch is conducting and the transformer is working. So if I adjust the amplitude on the function generator, it's also responding to that, and actually the voltage gets stepped up quite much, because this transformer is stepping up the voltage, and therefore now I'm in a very low voltage range on the function generator, and it's quite big on the output. So yeah, but this is working pretty good. This is working as it should. Yeah, so it's working perfectly fine. So this is great. And now let me check the switch. Now what happens if I flick the switch? Now it's off, of course, and let me flick it to on again, and the switch is working also, which is great. So now let me connect the function generator to the second input, and we have a signal. Great. And can we turn it off with the switch? Yes, we can. And we can, oh, okay, so this switch, the switch needs a bit of cleaning actually. So now it's on, off, on. Okay, now it's working, but I have to clean it anyway. So as you can see, it needs a bit of cleaning, but apart from that, it's working pretty good. And now I have to repeat the same test for the second transformer. Okay, so now I've hooked up the oscilloscope to the second transformer, like you can see right here. And I've hooked up the third microphone input to the function generator, and the switch is on the on position, so we should get a signal on the oscilloscope screen. And here you can see the oscilloscope, and it's working pretty fine also on the second channel. And now let me try the switch. Let's see if the switch is working. So now I switch it off and on again. Okay, and so the switch on this input is working as well, which is great. So now let's go to the fourth input, and let's see what's happening with the fourth input. And there we go. So now we have the signal on the fourth input, and actually the switch on the fourth input is quite dirty, but so I have to clean it with contact cleaner, but no problem. Okay, so let's continue with the test. So next we will check our friend the power transformer, and how can we do that? I cannot plug it in right away because I haven't replaced the capacitors yet, and I don't want to damage something with the broken capacitors. So what I can do is I can just unplug the rectifier tube, and by unplugging the rectifier tube, now I've disconnected the power transformer from the capacitors, and now the power transformer is only connected to the filaments, and the filaments of the tubes are good. We have tested it before. So I can connect now the power plug, I can turn it on, and I can check if the filament voltage for the tube, if the filament voltages are there. And with this I can ensure that the filament winding of the transformer works, and afterwards I will test the high voltage winding of the transformer as well. So as you can see, the transformer has multiple inputs for multiple different voltages, and now I've connected the voltage selector in a way which I think that it is connected for 240 volts. So I think now it's in the 240 volt range, but to make sure that it actually is, what I will do is I will use my adjustable transformer, and I will connect it to the input of this thing. I will connect my multimeter to the 6.3 volt filament, and then I will turn on the variable transformer, and I will see if it goes up to 6.3, and if I am at 230 or 240 volts on my variable transformer, and I get 6.3 something volts on here, then I know that I'm connected at the right way, and so I will do that right now. Okay, so as you can see, I've hooked up my multimeter to the filament winding of the transformer, and it's on volts AC, and I've connected the device to my variable transformer. It's up here. So here you have it, and it's at the moment it's at 0 volts, so I will start increasing the voltage soon. Let's go back to the device. So there we go. And one thing again to notice, the rectifier tube has been removed, so the only thing that's drawing current from this transformer is now the filament of the tubes, and so no capacitor should blow up or something else. So everything is safe, and now I start increasing the voltage on my variable transformer very slowly, and let me move it up. So now I'm at 100 volts at the variable transformer, and the multimeter shows 2.6 volts at the filament voltage. So it should be wired correctly. 150 volts, 200 volts, 230 volts. Okay, so now we are at the 230 volts, and we have 6.4 volts at filament, and so this is fine. So actually the transformer is hooked up correctly, and now the tubes should start to glow. So let me remove the multimeter first. So there we go. And as you can see here, the tube is glowing, so the filament of this tube is working, and the other should glow as well. So yes, indeed it is. You cannot see it maybe on camera, but this is glowing as well. Okay, so the filament heating of the tubes is working. So the transformer, the part which controls or which supplies the filaments, is working. So let's see if the high voltage is also working. Okay, alright, so now I've hooked up my multimeter to one of the secondaries of the power transformer, and now let's see what it does. So now let's turn on the device, and there we go. We have 181.6 volts. So this is what it should be, I think. So this is looking great. So let's see what happens with the other secondary of the power transformer. So first let me turn off the thing and reconnect the multimeter. So now we've reconnected it, and now let me turn it on again. And there we go, 182 volts. So this looks also pretty good. Okay, so this concludes that we have a working power transformer, which is great. So this is a candidate for a successful repair. This is just great. Okay, alright, so this concludes our evaluation of this thing. And by the way, the meter is also working because I've seen its needle moving before. So we can come to the conclusion that a repair of this thing, a successful repair, is possible, and some of the components have to be replaced, of course, and I will tell the owner that. And yeah, I'm pretty sure that he wants it repaired, so therefore there will be a second part. If he wants it to be repaired, then there will be a second part in which I will replace components and repair the thing, and then we can see it working. And yeah, so stay tuned for that. But this is the conclusion of this part now. And yeah, I hope you have enjoyed the video and maybe learned a thing or two. And yeah, I can say thanks for watching and bye.